The Charleville musket is the flintlock firearm with the highest numbers produced. Around 7 million, with the second place, the British Brown Bess, trailing far behind with only 4 million produced. While there are many studies and YouTube videos indicating the slight quality advantage of the Brown Bess in comparison with the French Charleville, it is the sheer production in which this French musket wins. It is the standardization and simplicity of assembly at large scale that carried the French infantry across Europe, providing a firearm that could be easily repaired and replaced. It is not for nothing that the Napoleonic Empire introduced the metric system across Europe, allowing the scaling and standardization of its weapons production, with different variants of the same gun using the same metal components that were interchangeable between the different musket variants. The nickname of Charleville comes from the main manufacturing town of Charleville, printed on many muskets. However, this standard pattern of musket was equally produced in other main arm manufacturing towns like Saint-Ouen, Toul and Maubeuge, with all guns receiving stamps of these cities. It is just that the name of Charleville carried through the ages to give this musket its name. This musket was the main firearm of the French soldier from the early days of the Republic until the final days of the Empire in 1815, with the last muskets produced in 1840. Let's now build this musket from scratch and look at its elegance and simplicity. Starting at the wooden base of the musket, we have the stock, made out of a single piece of walnut wood. This incredibly dense wood is still used today for guns and known for its good absorption of recoil, while easy to work with, allowing it to be shaped and carved according to a pre-planned measurement. A main bolt through the middle is used as the attachment point for the barrel. The barrel is created by forge welding iron strips using a rod-shaped tool, the mandrel, to create the barrel tube with a rectangular shape at the base, allowing strong connections to the stock with bolts. To further secure the barrel along the length of the stock, metal rings were placed at regular intervals, holding the barrel in place. The rings were made of iron and sometimes brass. These standard-sized rings were held in place with a simple spring system that could be easily pushed in to attach or remove the rings. The spring is embedded in the stock with a pin and can only be moved if the ring is removed. It is thus that the ring and spring hold each other in place. This system allowed easy removal of the barrel and easy replacement of rings and springs, improving the mass use of the musket. The front ring was slightly different in using a pin system and hole as shown here, but working on the same principle. To standardize the caliber size or inside diameter of the barrel was drilled out and smoothed using a drill of fixed size, driven by water or windmill power, giving all barrels the standard diameter caliber size of 17.5 millimeters. This allowed the Grande Armée to use the same cartridge and ball bullet size for all its hand firearms. The gunpowder of fixed amount was tipped into the barrel, after which the ball of slightly smaller diameter was pushed into the barrel together with the wax paper wrapping. With the use of a metal ramrod, the ball and paper were stamped to the bottom of the barrel. When not in use, the ramrod was slid into a carved groove at the bottom of the stock and held in place by the 3 rings. To further secure the ramrod, a simple spring was embedded in the middle of the stock. This spring pushed the ramrod tight against the outer rings, holding the ramrod in place and securing it tightly. A pin through the stock held the spring in place. To ignite the gunpowder at the base of the barrel, there was a tiny vent. The hole needed to be small for maximum buildup of pressure inside the barrel to propel the ball. The paper wadding was there to provide an extra seal, increasing the pressurization. As the ball was not fitting tight and smaller compared to the barrel diameter, the paper wadding was necessary to secure sufficient pressurization. This was a compromise, as it was known that tight-fitting balls were difficult to ram into a musket after fouling of the barrel through frequent use. Now we start with the main mechanical part of the musket, the transfer of ignition from the outside to the inside of the barrel. This transfer happens through the pan, which is a small metal bowl which is tightly fitted to the vent hole, as it is fitted tightly in place by a metal covering plate. The pan is covered by the frizzen, which is further attached with a screw, allowing the frizzen to open and close, sealing off the pan. We can now put gunpowder in the pan, which is now directly in contact with the vent hole, allowing transfer of ignition when the gunpowder in the pan is ignited. To make sure the position of the frizzen can be secured as either open or closed, a spring system is secured with a bolt to the outside of the metal plate. This makes sure the frizzen stays open or closed, depending in what position you push it. Now the hammer, the mechanism that can create the spark to ignite powder in the pan. The hammer holds a piece of flint, being wedged in between the hammer cap, connected to the bottom by a large adjustable bolt. The flint creates sparks when striking metal. It needs to scrape precisely along the curved metal strip of the frizzen cap, which thus functions as both a cap of the pan and ignition metal for the flint. The hammer needs to strike the frizzen with enough force to create the sparks. The mechanism to create this is hidden on the other side of the cover plate. First, there is the tumbler, directly connected to the hammer's axle. We attach a strong spring pushing the tumbler and hammer down, giving sufficient force to the system. Next is the sear, an independent handle mechanism turning along an independent axle close to the tumbler. The sear is equally attached to a spring that forces the sear down. When pulling the hammer back to the half position, we call this half-cocked, the sear spring automatically locks the tumbler in place, falling into a groove. The hammer and sear are both fixed. When we now pull the hammer back further to full-cocked, the sear is free to release the full tension of the hammer spring. To firmly attach this elegant and simple mechanism of two springs, we cover it with a bridle, attached with two bolts. Now we have a trigger mechanism, as we can transfer trigger action to the sear lever. We now basically have the whole musket. Let's remove the trigger mechanism for the moment and finish off the outside attachments. First, the trigger itself and the trigger guard. The trigger metal guard fits into a carved out groove at the bottom of the stock and is bolted at the back part. The trigger fits into the tight metal slit, fixing the trigger's movement to the front with a metal pin through the stock fixing the trigger. The trigger guard is placed on top, slotted in at the back and fixed at the front with a metal bar and pin. Now, looking at this mechanism through the stock, we can see how the sear spring gives tension to the trigger. Okay, now we're almost done with building the musket. We just need to put some final finishing touches. The metal ring by the trigger guard is there to attach a strap holder at the back, allowing the infantryman to carry the musket over his shoulder. A similar strap holder can be attached at the front to the middle ring. We can now attach a strap to the musket if necessary. A final piece of metal is attached to the back, the butt plate, giving extra reinforcement and allowing the infantryman to use the musket as a club. The Charleville musket is now finished as a firearm, but not necessarily as a weapon. We need to attach one more thing: the bayonet. The easy-to-use slotting mechanism allowed quick and easy attachment, with a securing ring fixing the bayonet in place. The bayonet on top of the musket allowed the infantryman to function as musketeer and pikeman of old at the same time. The bayonet could be easily slotted on and off and was placed enough to the side that infantrymen could be easily trained to continue to load and fire with a bayonet attached. This was made easier as the blade did not have a sharp edge, only functioning as a pointy stabbing weapon. The combination of the relatively long musket with a bayonet on top created a decent length pike, allowing a group of infantrymen to quickly change from a group of volley-firing musketeers to a wall of pikemen, stopping cavalry in their tracks. The efficiently produced Charleville with standardized cartridges, easy assembly and repair became the ideal weapon for a mass conscription army like the Grande Armée. The weapon would be used across the world as an easy-to-produce musket, but no army used it more efficiently than the French Imperial Army during the Napoleonic Wars. Many thanks for watching this video all the way to the end. I really appreciate it. I hope you enjoyed it, and of course it would help if you give the video a like and subscribe to the channel, as I really enjoy making these videos. Leave a comment if you disagree with my analysis or any other comment. I will make sure I respond, and I'm always happy to learn more. I hope to see you again in the next video.